Hey folks, how you doing? We're going to go ahead and get started. So today we're going to be talking about the Open Policy Agent. We're going to be doing a deep dive. But before we get started, and we'll do questions at the end like always. Before we get started, let's get a sense as to who here has used OPA before. OK, and then so if you haven't ever used OPA, raise your hand. All right, very good. That's helpful. All right, of those that used it, who's used it like in production? You've actually rolled it out. Got a couple. OK, good. All right, that's helpful. All right, we'll go ahead and get started. First, who are we? Well, my name's Tim Hinrichs. I'm one of the co-founders of OPA and the CTO at Styra.
And I'm Torin Sandall. I'm an engineer at Styra. I'm one of the other co-creators of the project. I'm also T. Sandall on the OPA Slack. So you may have talked to me on OPA Slack at some point. So without further ado, I'm going to let Tim get us started.
What we thought we'd do, even though this is a deep dive, and this works out well given how many people have not used OPA, we thought we'd do a quick overview of the OPA project, why it's useful, and then a bit about how it works. And then we'll go on and talk a bit about some of the recent developments and then some of the future work that we're going to be carrying out over the next couple of months. All right, so the way we thought we'd get this started is to just talk about a simple application as an example. Right? Applications, we build them all the time, or at least some of the folks that we work with do. And in this application, it's sort of a standard end user application. We've got Bob, our end user, logs into a portal. It's maybe some sort of banking app. Here we've got payments and accounts and promotions. Those are all microservices. That's great. And they're all backed by some sort of storage, right? S3, maybe we're running on Amazon, SQL for standard relational stuff. Maybe we're using some partner APIs or some third-party APIs like Twilio or Stripe. And so one of the observations that we make is that in this kind of application, there's a bunch of authorization. There's a bunch of policy that needs to be put in place for that end user, right? So Bob, our end user, is authorized to read the balances on his accounts, but obviously not everybody's accounts. We also know that there's different kinds of authorization sort of at the next layer down, sort of at the microservice layer. So maybe payments here is authorized to talk to accounts, but accounts is not authorized to talk to notifications, right? That's another kind of authorization. That's another kind of policy that we end up having to put into our applications. We also have Alice, who's one of our developers. She also has access to all of the different kinds of components of this application. She has access to the database. Why? Because maybe sometimes when she's on call, she has to debug what's going on in production. She needs to look at some of those records. She also has access to the microservices and to S3, right? Again, Alice is another stakeholder in this game where authorization and policy is important. Who can do what is important for both of these end users as well as the microservices that you see on the screen and for other kinds of stakeholders as well. Maybe you're talking about the security team has certain rights. Maybe you're talking about the customer support team, which sometimes gets to look at database entries that correspond to customers who've opened tickets against the application. At the end of the day, there's authorization and policy spread throughout this application. The challenge here, well, at least one of the challenges is, though, that before OPA, often it was the case that every one of those microservices was built by a different team, and therefore each one had its own way of solving the authorization problem. Each of the databases, certainly SQL, we've all used grant and grant statements in SQL. That is a different authorization system. S3, if you're running on Amazon, it's got its own authorization system. So there are different kinds of authorization systems that are set up and that are sort of our building blocks that we as application developers, as platform engineers, as security personnel, as compliance officers need to think about and use in order to implement those global authorization policies that come down in wikis and PDFs. So there are a bunch of obvious questions here, right? So once you've got all of these different kinds of authorization systems, how do you use them? If somebody comes down and says, here's a new rule. Alice can only access production databases when she's on call. She can only SSH into production servers when she's on call. How do you implement that? How do you enforce it? Right? You have to know and understand several different APIs, several different authorization models for each of the different components of that system in order to implement those policies. Likewise, if you think about a question of compliance comes along and says, prove to me who can access what. Again, you've got to go into each of those different systems. You've got to understand how they work. You've got to pull out who can access what from each of those different systems, aggregate them together, and return a result to your compliance officer. Another good question that comes up is data. Like, authorization is not something that is typically done in a vacuum. Often there's a bunch of external data about what's going on in the world that's important to make those correct authorization decisions. For example, in an org chart, maybe managers have different rights than individual contributors. And so that kind of data, or for the end users, another good example here is maybe I've got 100 million users. Obviously, who owns which object is an important piece of data that I need in order to make authorization decisions. So how do you fold that in to the authorization landscape? All right. But the problem doesn't end there. It's not just an application problem. Many of us here today are probably working on Kubernetes in some way, shape, or form, or some other platform. Maybe we're running that application on VMs. Maybe we're running it on bare metal. Here we've got an example of running that application on Kubernetes. And we have the same kind of picture in the sense that there are all these different components. We've got ingresses set up to serve the payments URLs. We've got the payments pods running on nodes. We've got persistent volumes that are connected to those pods. Again, all of those different components are something that, especially if we're embracing DevOps, Alice, our developer here, has access to. She's going to be able to put those persistent volumes in place. She's going to be able to launch deployments and ingresses and so on and so forth. And our administrator, Amanda, is going to want to put a bunch of guardrails, a bunch of safeguards around those different components of the platform. Those safeguards are just another kind of authorization. That administrator is just authorizing the developers and the operators and the platform engineers to put certain resources in place with certain configurations. We've got good examples around ensuring that all the images that get deployed onto my cluster come from a trusted repository. The administrator is going to want to make sure that all ingresses that get deployed never conflict with another ingress. Again, that's just another form of authorization. The admin is going to want to make sure that every pod, every deployment is affixed with CPU and memory limitations to make sure that they don't eat up a bunch of resources. All of these are different forms of authorization. And so this is the problem that we set out to solve when we started OPA. There are all kinds of different authorization throughout your stack, and that makes it hard to deal with the actual authorization problem in the real world. You've got to take those authorization policies from the real world and implement them across many different layers of the stack using many different APIs, authorization models, and authorization systems. OPA was designed to unify policy enforcement across the stack. So here's the picture that we usually like to show at the booth. Come by if you haven't already, to show all the different components, all the different integrations that exist for OPA, right? So we've talked about microservices down on the left-hand side. People often ask, what about how does OPA correspond to Istio and Envoy and Linkerd and so forth? We've got integrations with all of those. If you think about risk management on the public cloud, again, there are people using OPA to do that kind of public cloud authorization. Data protection, container execution, SSH and sudo. These are all integrations that OPA has out of the box. One of the most popular is Kubernetes admission control. This is something that we highlighted on that last slide because so many people using OPA are starting to use it for admission control. How does that administrator for Kubernetes put safeguards on the cluster to make sure that the developers don't make mistakes? So what is OPA? OPA is a general purpose policy engine. And what that means is I think of general purpose in really two dimensions. We've already touched on one dimension, which is that you can take OPA and you can use it as a policy engine for many different types of systems. Think about it as spanning all the traditional silos of compute, networking, and storage. Any one of those services you saw on the last slide, any one of those services you see on that upper right-hand corner are services that you can integrate with OPA. And then the idea is that regardless which service that is, that service at some point in time needs an authorization decision or it needs a policy decision. And so that service will ask OPA, it'll say, here's some information, here's a JSON object that represents an HTTP API or a Kubernetes admission review request. It hands that chunk of JSON to OPA. OPA makes its decision using Rego, which is a policy language, and any external data that you happen to inject into OPA. OPA makes a decision and it returns it to that service. The service in turn takes the decision and does the enforcement. Right? So one key idea behind OPA is that we're trying to decouple policy decision making from policy enforcement. It's a service's job to do the actual enforcement. It is OPA's job to make the decision. So that's one sort of dimension that we've articulated. OPA can be integrated with many different systems across many different layers of the stack. That is, in one sense, why it is general purpose. The other dimension in which it's general purpose is that the policy decisions that OPA makes can be allow, deny. They can be true, false, standard classical authorization. But the decisions that OPA makes can also be arbitrary JSON objects. So let me give you a few examples. If you want to think about policy decisions that end up as rate limits, OPA would return a number. If you want to return, let's say, a host name that describes which host you're supposed to connect to, OPA would return a string. If you're returning an allow, deny decision, OPA returns a true, false. If you're returning the list of clusters to which you should deploy this application, you would have OPA return an array of those cluster names. And in Kubernetes case, we use this all the time, if you want to, for example, return a Kubernetes object, an API, an admission review response, that would be a full JSON object. So regardless what kind of information you want to return, as long as you can shove it into JSON, you can use OPA to make decisions and return those decisions to the calling service.
All right, so that's sort of an overview of the problem space that OPA operates in. And what we thought we'd do is give like a little bit of an update about where we're at with the community, because over the last year or so, we've seen quite a bit of growth. So this time last year in May in Copenhagen, OPA had just joined the CNCF sandbox, and we had 2 talks at KubeCon where we were focusing exclusively on OPA. So that was the first time we presented OPA on its own and talked about it sort of as it exists. And at the time, over the last, or basically the year before, all of the commits, all the contributions that came into the project were from Styra. We were seeing about 1,000 image pulls per week, and we had a couple hundred people on Slack. But over the last year or so, we've seen quite a bit of growth, tremendous growth actually, in terms of the number of end users, the number of people that are using the project. And so that was recently reflected in OPA's promotion to the incubating tier within CNCF, which we're super excited about. And it's also reflected in some of the other sort of signals that we track about OPA's growth. So over the last year or so, we've seen the contributor diversity increase. It's now 75% Styra as opposed to almost 95%. But the other numbers are also really encouraging as well. So we see about 25,000 image pulls per week for the OPA Docker image. We've got over 800 people on Slack now. We've got over 2,000 stars. And recently we started tracking the number of public repos on GitHub that contain Rego files. And that's a super interesting metric because it tells us how much people are actually really working with it for real. And so one of the things that's been driving a lot of this adoption has been a bunch of related use cases around putting guardrails over configuration, right? So primarily this is around Kubernetes admission control, but it applies equally across a bunch of different platforms like GCP or AWS, or if you're using Terraform, or really any kind of structured data, right? So all of these platforms, all of these infrastructure services basically expose their configuration, their desired state as structured data and let you control it, right? So that you basically end up handing over control of compute, network, and storage resources to developers within your organization. And they have the ability to do things like to set up network policy or control, resource allocation or control application ingresses and so on, right? And so if you're not careful with those, what many organizations find is that it's very easy to shoot themselves in the foot. And so OPA, a lot of companies are using OPA today to solve policy-related, problems around these platforms. And I think one of the main reasons for that, why OPA is a good fit for that problem, is because the language that OPA gives you is really, really good at helping you reason about structured data, right? And that's really what configuration, is at the end of the day. And that structured data is quite complex, right? Like, who here works with YAML on a daily basis, right? Basically every single hand just went up. And in that YAML, how often is it just like a flat YAML file where it's just like a map of a string to another string? Right? Like one hand, okay, 2 hands, never, right? You basically always have these super deep, complex, YAML objects that you're interacting with, right? And what OPA's language is really good at doing is basically helping you codify policies and constraints and rules and so on over that deeply nested structured data. The other thing that people have started to pick up on lately is the importance in the duality between enforcement and auditing, right? So A lot of people are using OPA just for admission control today to enforce admission policies in their clusters. But one of the nice attributes of OPA and its policy language is that it lets you write one policy and then ask different questions of that policy. So obviously, you can deploy that policy and have it ask the question, should this pod be created in this namespace? But you can also use it to ask the question, what resources in my cluster would violate this policy if the policy were to be deployed? And that's super helpful for compliance purposes. It's super helpful for gaining confidence in your policies before you deploy them, and so on. But there are a number of other interesting use cases that I just want to highlight today. One of those is just around application authorization, which we talked about a minute ago. So Chef recently open sourced all of their proprietary code. And one of the products that they have is Chef Automate. And Chef Automate has an IAM capability, right? Every time you ship an application to enterprises, it needs to have some sort of authorization, identity and access control system built into it. And so recently, Chef decided to build their IAM capability on top of OPA. And so one of the most common questions that we get in Slack from people once they sort of try OPA out for the first time is, how should I think about policy? How should I define my permission model, my access control model? And so Chef has done a lot of work to define a role-based access control model and a project-scoped access control model, which they've gone and documented and described really well. They've also sort of documented their architecture. They've described how they integrate OPA as a library, how they deal with policy storage, and so on. So if you're trying to think about how you can use OPA in your application, this is a great reference to check out. Just another example that came up recently that we thought was kind of interesting was this RPG combat rules engine that Kevin Hoffman built. So Kevin was doing a bunch of experiments with OPA, and I guess when he sees new technology, he likes to see how he can use it to make video games better. And so he basically used OPA's policy language as basically what he said was that OPA is like a deferred brain to which I can pass relevant information and get decisions in return. Right? And so I think that this really illustrates the general purpose nature of OPA, the fact that it is very flexible and it's very powerful. And if you're interested in that post, there's a link in the slides that you can check out. OK, so what have we been working on lately? Well, the first thing that I want to talk about is this new thing called the Playground, the OPA Playground. So if you go to play.openpolicyagent.org today, you can just try this out. We released this earlier this year, and we've seen a lot of people really enjoy using this to try out OPA with. Basically, it's inspired by the Go playground and other online playgrounds. But what it lets you do is really quickly experiment with policies in the browser, which is really nice because it has this really fast feedback loop that lets you iterate on the policies and see the results of them and build up intuition about how the policy language works. And it also has this nice publish and share feature where you can basically just get a link and then send that to your coworkers or something like that. So what I thought I'd do is just kind of give a little bit of an example of how this works. And so this is going to load, assuming we have internet, which we do. So I'm going to make that a bit bigger. So this is just a simple admission control example, right? This is actually just pulled out of the OPA documentation. This is just a deny rule. It's just a rule called deny. And it basically says that deny will contain a message if the input is an ingress object, and that ingress object has a host, and there's another ingress object that exists inside of OPA that's been loaded in that has the same host name as this one in the input. And if that's the case, then we generate an error message. So this is basically checking for host name conflicts in ingress objects in a Kubernetes cluster. And I've just gone and hard-coded the external ingress below here for demo purposes. So one of the nice things about this is that I can just hit output here, and the policy gets evaluated, and the result gets printed here. And so you can see that right now there's a single element in the deny array. And the reason for that is because I've got input as well, and I've defined the input document in the browser here, and I've specified basically the admission review webhook object. And so that's basically the full Kubernetes YAML file, effectively just represented as JSON. And so I can basically put this JSON data into the browser and evaluate the policy and see the output. But it's a little bit more powerful than that, because what I can actually do is I can select arbitrary parts of the policy and evaluate those as well. So if I just select deny here and hit this refresh button, now it tells me the value of deny. Right? And so that's giving me the same answer that you saw a second ago, but it's a little bit more tightly scoped, which is nice.
But you can go even further than that. You can actually select like arbitrary parts of the rule. And so if I just go down here and I select this part of the rule body and I hit evaluate, then it basically prints out the values for the variables that OPA found that satisfy the rule, right? And so just the fact that I can go in here and I can edit these rules and I can edit the input and I can try it out is super valuable from sort of like an education perspective. So it's a little bit hard to type and select at the same time, but OK, there we go. So there, I changed the input, and now it's no longer conflicting, and so I get an undefined back. So anyway, so this is the playground. I recommend that if you're trying to, if you're playing with the language, you're trying to learn how to write policy, try out the playground. It's super useful. I think it's a powerful tool to get started with. So along the lines of helping you kind of like work with policies and debug them, one of the things that we found is that OPA has this feature called tracing, which you can enable when you do a query. And by default, the tracing feature returns a lot of information. And sometimes that's useful, but sometimes it's also a little bit confusing. OPA also has this thing called the trace built-in function, which lets you emit a message to the trace. It's like a print statement, basically. And that's useful for debug purposes, especially if you're coming to OPA from just like a standard imperative programming background where you just want to stick a print statement in and see the value of some variable, right? The problem before was that these trace event notes got kind of hidden in the overall trace. And so it was difficult to understand, like it was difficult to just find the values of basically your print statements. Now, so in the new version, the latest version of OPA 0.11 that we released this week, there's a new feature that allows you to just filter down the trace events to only the notes and the relevant context from the trace. So if you've used the OPA tracing feature before, or you've tried to use the notes feature a little bit, check this out. It might help you debug your policies a little bit better. Another thing that we've been sort of looking at lately are improvements to the language. And one thing that we saw become a little bit of an issue in large policies, very large policies, was the fact that by default, variables will basically capture global values. So what that means is that, like in this example, in the before case, user in the body of the rule actually refers to the global user that's defined outside of the rule. And this is often really nice. It allows you to write very kind of readable policies. But at the same time, it can be frustrating because if you introduce a global, it might change the behavior of some of your rules. And so it can be kind of confusing in certain cases. And so early last year, we introduced an assignment operator, and that resolved a lot of these cases. But there were some other cases around pattern matching and reference operands that didn't get handled by that aren't handled by the assignment operator. And so to address those cases, we've introduced a new keyword to the language called sum, which essentially allows you to explicitly declare local variables within the body of a rule or within a query. And so that avoids this capturing problem that people run into when they have very large policies. And so the last thing that I want to just kind of touch on is an update around what we've been doing with WebAssembly. So I talked about this a little bit in Seattle in December. Basically, in v0.10, we added experimental support for compiling OPA policies into WebAssembly. WebAssembly is basically a binary instruction format for executing virtual machines. And it's being used for a bunch of different use cases. A lot of people are excited about it, allowing you to run native code in the browser, but there are a bunch of non-browser, non-web embeddings that are also very interesting. And because it's designed for the internet, because it's designed for the web, it has really nice properties around safety and efficiency and portability that make it an ideal runtime for policy evaluation. And so the goal of this WebAssembly integration, this WebAssembly compiler, is to basically allow you to embed OPA policies and have them evaluated in any language or any runtime, right, without requiring a standalone daemon to run alongside your application. And so the way this basically works is that we've just extended the OPA compiler to basically, instead of just emitting an AST that gets interpreted in Go, we emit WebAssembly. And then that WebAssembly can be run by any WebAssembly runtime, right? So V8 and a number of others. And so in the latest release, we've expanded the scope or the fragment of Rego that's supported by the WASM stage. to the point where all types of rules now can be compiled down into WebAssembly. So we're very close to having basically full coverage of the language. And once that's finished, we'll start to see library integrations in Node and Python and Ruby and so on. And we recently also created an example that shows how you can take this and run it for a use case on top of a CDN like Cloudflare. So if you're interested in this, go to the Open Policy Agent contrib repo on GitHub and check out the CDN example there. And so with that, I'll hand back to Tim to talk about where we're going.
Thanks. Yeah. So looking forward, what are we going to be looking at over the next few months? There were really three things that I wanted to cover. One of which is that this summer, the Google Summer of Code, we're going to have a project around building an IP tables integration. So Urvil Patel is an undergraduate, and the Crushinator is one of the community members who's mentoring Urvil. And so the idea for this particular project is pretty simple. It is the same diagram that you saw near the beginning of the talk. Here, though, the decisions that OPA is going to be making is sort of the desired state for the IP tables running on Linux. And then the controller that Urvil is implementing will go ahead and periodically poll OPA and say, hey, give me the desired state. Then it'll go ahead and render that desired state down into Linux IP tables. All right, so a classic sort of implementation of OPA in some sense, but this does have the hallmark of like a Kubernetes controller. It feels very similar, right? Give me the desired state, and I'll make sure that is rendered down on the actual software. All right, so that's happening. Thank you to CNCF and Google for sponsoring this year. Second thing that I wanted to cover was that when we started out, the very first example we gave of authorization is really around this end user and application authorization. Right, where you've got an application, you've got a bunch of different authorization issues that you need to solve. And so we had also on the slide a bunch of different questions there on the left-hand side. I only touched on a few of them when we talked through them. But so what we did on this slide was we went through, and for each of those questions, we showed the answer that OPA provides and put a progress bar indicating how far along we were in answering that particular kind of problem. So in terms of a couple of examples here, so the red ones and the yellow ones are the things that we'll be focusing on over the next, 6 months or so. And so I'll highlight a couple of those. One of which is that, as Torin described, one of the things that Chef did that was very useful in this space was to go ahead and demonstrate how you could use OPA to build end-user authorization inside their application and layer on like a multi-tenant kind of RBOC model. And so that kind of thing that's coming out of companies like Chef that have like forged the way and shown here's how I found that it was useful to build my internal authorization for my application. We're going to be exposing and building out some of those same models and making them available to more folks so that not everybody has to reinvent that wheel. So that's one thing that we'll be looking at. Another is that we talked a bit earlier about data. And so a lot of authorization decisions need a bunch of data in order to make those decisions. If you've got 100 million users, typically what we'll do in OPA is we'll say, you should load your data into OPA before asking it to make a decision. If you've got 100 million users, it's going to be very difficult to load all of that data about who they are, what objects they own, and so on and so forth into OPA. There's just too much data. And so there are a couple of efforts that we've already, I think we talked about at the last KubeCon, one of which we call data filtering. The idea being that we take policies that you write in OPA and we compile them down and execute them in SQL. Right? So we basically add where clauses to SQL before they get executed. And so that's something that we'll continue working on. And similarly, one interesting case that we've run into is when there's just too much data to load into OPA. And moreover, during policy evaluation, people have asked, hey, I'd like OPA to reach out into the world, grab some additional data, and make decisions. And so here, we're calling that data fetching. So that's something that we have some very early, very experimental support for, but it's something that, again, we'll be investing in. The other couple of items on this list are really amount to WASM compilation. So one of the questions here is, well, it's great, but to have OPA running as a sidecar next to each of my microservices as part of my application, that's something that we see people do quite often, but that doesn't work for my front end. How do I, in JavaScript, get that same kind of policy information if I, as a front end developer, need to decide whether to render a button or gray it out or shrink the list of objects and resources that I show the user? So WASM is certainly a good candidate for helping address that problem. All right, I think that's it. One last thing that I'll cover before Q&A is that one of the things that we're also hoping to work on, and we'll need some of your help for this, is that we want to make a lot of the policy language more discoverable than it is today. By discoverable here, I mean, whenever I pick up a new language, or even if I'm just rusty on a language, I'll go to Stack Overflow and search for how do I iterate over dictionaries, and then Stack Overflow will just give me that exact answer. Today, a lot of that same Q&A is done on Slack, which means it's much harder to discover, it's much harder to search for. So one of the things we'd like to do, and we'd like to ask you all to help us with moving forward, is that when you pick up OPA, when you come on and start asking questions on Slack, please go ahead, and we'll probably ask you this, to go ahead and also post those questions on Stack Overflow and tag them with Open Policy Agent so that we can go ahead and answer them there and make them searchable for everybody else. So that's something that we're hoping to do as well. And that does it. So now we've got some time for questions. And I would also point out that there are a number of talks on Open Policy Agent and activities around Open Policy Agent here at KubeCon. So go ahead and just search for OPA, Open Policy Agent, on the schedule, and you'll get this list up here. All right, questions, comments? None? There we go. Yeah.
Hi, this question is regarding Envoy integration of OPA, basically. So it looks like it is integrated with an external auth filter, right, today. So suppose I want to do a subject alternate name validation, and I pass the certificate details to OPA and create an OPA policy in the OPA agent. Can I do regex validation on this SAN today? Or is it in your roadmap to support regex validation of SANs?
Yeah, so right. So the question was, I'll boil it down to, do you support regexes today, I think is the short version. And so yes, there are. OPA has over 50 built-ins, including regexes and globs and basic string manipulation. So there is go to the website, look for language reference. That's usually the one I refer to every now and again. But yeah, 50 plus built-ins. Yeah, and they're easy to add. So if there's some that are missing, it's very easy to open a PR. Yeah.
When we were testing our OPA policy, or trying to unit test our OPA policies for Kubernetes, hand generating all of the JSON requests to match the Kubernetes stuff was painful and seemed like something everybody's going to have to repeat. Is there any plan to write some helpers to write to unit test Kubernetes policies?
Yeah. So, well, do you want to answer this one?
So the question is around how do you actually bad feedback. How do you get the data that you're going to use in your unit tests, like when you're writing Rego? And this is something that I think we've all probably experienced the first time we do it. We don't have great tooling right now. I think that, so one feature we recently released is just a standard out decision logger to OPA. So if you just deploy OPA on Kubernetes, you can just see the decisions that it's making. And that's often very useful for just capturing, basically the inputs that Kubernetes is providing to OPA, basically in your environment. I think there's other interesting things we could do around creating collections of test inputs and so on. But a lot of the time, this is obviously very specific to your environment, and so I think that's an area where tooling would really help.
Yeah, and so for the rest of you who didn't realize, OPA does have a unit test framework, and we highly recommend using that. Right, especially if you're deploying OPA in Kubernetes as an admission controller. Do not just write your policy and shove it into OPA and then start debugging there. Write your unit tests just like you would for normal code, get it working there, and then push it into Kubernetes. Yeah. Anything else? Here, I got that. Where'd you go?
What are the current efforts for data fetching? What are they focused on at the moment?
Oh, I got both. So yeah, data fetching is it's new. It's something that we're going to be putting more time into. Right now, we have an HTTP send built in, which basically just during policy evaluation, you can send an HTTP request to a server and get a response, and then obviously that's JSON that comes back in, and then you do the usual kind of Rego thing to process the result. So that's what's there today. And then we've just had a number of issues raised over the past few months asking for more sophisticated kinds of functionality. So like different graph databases, for example, would come up.
We also, I think the Crushinator from Cisco is working on adding LDAP support as well. So being able to query LDAP at runtime, at policy evaluation time.
Do you plan also to add the new firewall rule set like NF table instead of IP tables for OPA?
Other kinds of firewalls?
So adding other kinds of firewall rules. So we don't have plans today. So this IP tables just came up because people asked for it several times. And then we had a student that proposed a solution to that, proposed it. So it was, yeah. One more. Yeah. So the question was, she's not using OPA yet, but she's thinking about it and wants to know how flexible the language and schema are. My rule of thumb is that you are typically more limited by your imagination than you are the language. That's honestly what we find is like people think, oh, it's like, in the old, typically people think, well, here's networking policy, so you've got 5 tuples or 7 tuples. Or it's like storage policy, so you've got some pre-built stuff in there. OPA doesn't build that stuff in. And what that means at the end of the day then is that it's, in order to solve all these different use cases, it has to be flexible enough to solve them all simultaneously. So there's tremendous flexibility there. Yeah. All right. I think we're over time.
All right. Well, thank you all for coming by, and don't forget to stop by the Styra OPA booth as well.
Yep.